Hello students, welcome to Spirochemistry. So this is the lecture number 2 of name reaction. In the lecture number 1, I will discuss about the mechanism of aldol condensation reaction briefly. So if you guys not seen yet in the lecture number 1, you must watch it, and I will provide this the link of lecture number 1 in the description box of lecture number 2. You must watch it. I will briefly discuss about the mechanism of aldol condensation reaction. So let's start the lecture number 2. So in today's lecture, I will discuss about the intramolecular. I will discuss about the intramolecular aldol reaction, intramolecular aldol condensation or intramolecular aldol reaction. In the intramolecular aldol reaction, there is 1,5 or 1,6. There is 1,5 or 1,6 dicarbonyl compound. There is 1,5 or 1,6 dicarbonyl compound, which form a condensation, which form a intramolecular condensation, aldol condensation reaction, 1,5 or 1,6 dicarbonyl compound, and form a 5-member or 6-member ring. 5-member or 6-member ring. We already know that 5 or 6-member ring is more stable. So suppose there is a compound CH3, CO, CH2, CH2, CH2 and C double bond OH. So here is 1, 2, 3, 4, 5, 6. So we can see that here it is 1,5 dicarbonyl compound, 1,5 dicarbonyl compound. If you give OH minus and heat, we already know that there is a aldol condensation reaction, and in one type of reaction is present here, aldol condensation reaction, that is intramolecular aldol condensation reaction. So there is, we know that in aldol condensation reaction there is a alpha carbon is present there, alpha hydrogen is present there. So here we can see that it is alpha, and along with it is also a alpha carbon. So here alpha, if you take this alpha hydrogen, suppose we can write here 1, and hydrogen is attack here, and it form CH3, C double bond O, CH minus, CH2, CH2 and C double bond OH. And this carb anion is attack here, and it form 1, 2, 3, 4 member ring. So we already I already told that 4-member ring is not a stable compound. 5 or 6 member ring is a stable compound. So this reaction cannot happen. So in the real, if you take this alpha hydrogen, it forms, suppose CH2 hydrogen, C double bond O, CH2, 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 C double bond OH. If you take this alpha hydrogen, OH minus is attack here, and it form a carb anion, CH2 minus and C double bond O, CH2, CH2, CH2 and C double bond O hydrogen. So we can see here that 1, 2, 3, 4, 5 and 6 member ring, and it attacks here, 6-member ring is formed. So 6-member ring, in the one position there is O minus, suppose 1, 2, 3, 4, 5 and 6. I already told that there is a 6-member ring is more stable, and the 6 and the 5 there is a O double bond O, and it form OH and C double bond O, and a hydrogen is present here. Alpha beta unsaturated product is formed in intramolecular in aldol condensation, and what is the product? Product is C double bond O, and here is a double bond. Another suppose another compound is that suppose CH3, CO, CH2, 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 CH2 and CHO. So we can write here the 1, 2, 3, 4, 5, 6 and 7. We already told that 5 member or 6 member is more stable. If you take this, if you take here is a 1 is alpha, here is alpha and here is alpha carbon. So if you take this alpha carbon, if you take the hydrogen from this alpha carbon and there is a form 7 member ring. See that 1, 2, 3, 4, 5, 6, 7 member ring which is unstable, we cannot write here. So if you take this alpha hydrogen, what is the product? This alpha, if you take this alpha hydrogen, CH3, C double bond O and CH minus, CH2, CH2, CH2 and CHO, and the heat it attacks is here C double bond O, suppose C double bond OH, and it form a 5 member ring. 1, 2, 3, 4, 5 member ring. What is form? Form like this C double bond O CH3 and here is a OH, here is a OH, and we can see that in this carbon there is one hydrogen present here and it attacks and it form 5 member ring and a C double bond O, C double bond O CH3. So that's it, the intramolecular aldol condensation reaction. This is very simple. So in the today's lecture I will discuss about a very important name reaction which is Claisen-Schmidt reaction. Very important name reaction. This is Claisen-Schmidt reaction. Claisen-Schmidt reaction. Claisen-Schmidt reaction. So what is Claisen-Schmidt reaction? Claisen-Schmidt reaction is that one aromatic aldehyde is present. One aromatic aldehyde is present which have no alpha hydrogen. Which have no alpha hydrogen is present. Which have no alpha hydrogen. And another is aliphatic hydrogen. Another is aliphatic hydrogen containing alpha hydrogen, and aliphatic aldehyde or ketone containing alpha hydrogen. Aliphatic aldehyde or ketone, aliphatic aldehyde or ketone containing alpha hydrogen. This type of reaction is called Claisen-Schmidt reaction. So what is the mechanism of Claisen-Schmidt reaction? Suppose there is a example of Claisen-Schmidt reaction is suppose C6H6 C double bond OH. There is a aromatic aldehyde. It is a aromatic aldehyde. We can write that CHO. So there is no alpha hydrogen is present. No alpha hydrogen is present here. No alpha hydrogen is present here. And another, suppose aliphatic aldehyde, suppose aliphatic aldehyde HCH2 CHO. There is a alpha hydrogen is present here. There is a functional group CHO, and alpha hydrogen at the site of the carbon is called alpha carbon, and alpha hydrogen is present here. And in presence of KOH, 10% KOH, dilute solution of base, and dilute solution of base, it form just like aldol condensation reaction, C6H5CH OH CH2 CHO and minus CH2O. So it forms C6H6 CH double bond CHO. This is the reaction. What is the mechanism of this reaction? Now the mechanism is that without mechanism any name reaction is not possible. So mechanism is that Suppose here present C6 H5CHO and another is CH2CHO, and we take the base OH minus and it attacks here and it form a CH2 minus CHO. This is the nucleophile. This is the nucleophile. We already told in aldol condensation reaction. So this is the nucleophile. So CH, C double bond OH, and it attacks CH2 minus and CHO, and it attacks here and it form pH C O minus hydrogen, so CH2 CHO, and it attacks OH, so it takes hydrogen from this and it form pH OH hydrogen CH and CHO. If you give heat this reaction and it release the water and it form alpha beta unsaturated product is called CH double bond CHO. This is the product, and this is called cinnamaldehyde, and this reaction is called cinnamaldehyde.